Alright guys, a quick overview of the answers from yesterday. So the first three problems you were graphing. So in number one was in standard form. So then I went ahead and found the x and y intercepts. So the y-intercepts down here at -6, the x-intercepts over here at 4. Then I just connected them with a line. Now number two was an inequality, so that meant that we needed shading. It was not including, so it had to be dotted. And so with that one, I started at 1 on the y-intercept, and then went up 2 over 1, up 2 over 1. Then I also went down 2 over 1, down 2 over 1, just to make sure I had a full line. Had it be dotted, and the shading was below. If you don't remember where to shade, you can always just plug in a test point. If you plug in something like 0, 0, you would get that 0 is less than 1, which is a true statement, so you shade towards 0, 0. Now the third one was a little harder because that was in point slope form. We didn't really do any of that in class, but we could have still manipulated this equation and gone from there. So I distributed the 2/3, added the 4, and I got this equation in slope-intercept form. But if you recall, this is point slope form. So this 1 and this 4 are going to give me my coordinate point, and the 2/3 is my slope. So then I go over to -1, +4, that's this point right here, and then I went up 2 over 3 and down 2 over 3 to get my line. Number 4, the part that was a little confusing was the wording. I wanted the average rate of change. The average rate of change is the slope. So if I were to plug in 3 into this equation, I get -16. If I plug in 5, I get -46. So therefore, that means that over 2 units, this function decreases by 30 units, or on average, 15 units for every 1 unit. And that's slope. And then lastly, number 5, you had to distribute, combine like terms, get the variables on one side, constants on the other, multiply by the reciprocal, and you get 10/3. Hope this helps.